Hey guys, welcome to Xamarin University and welcome to our recording of AND210. This is our Android Services class. I'm Jason DeBoover. I'm going to be your host while we discuss how to create Android services. Of course, like all of our classes, this class does include some downloadable course materials, so as you watch the video, you'll also want to follow along with those course materials. We of course have the starthere.html, which tells us what's going on, but also will provide you guys your own copy of the slides that I'll be presenting. And like all of our classes, this one includes exercises. So while you're watching the video, and you'll of course be able to see me going through the exercises, these are intended as individual exercises. So I highly encourage you to pause the video when the time comes when we get to these exercises. Pause the video, go through the exercises yourself, and then you can come back to the video and watch me go through it and kind of explain things to you. Of course, when the time comes, I'll tell you, for instance, exercise 2, you'll click here, you'll see what you need to do, and in fact, if you scroll down, you'll actually get step-by-step instructions. You're also welcome to skip the step-by-step instructions and just try to read the challenge and accomplish it yourself. We've also got some additional reading down here, so after going through this class, you can dive even deeper by clicking on these links and reading away. Now, back to my slide deck. And we're ready to get started with our AND210 presentation. During today's class, we'll learn how to create a service, of course, how to start that service, how to elevate the service to the foreground and what that means, and how to bind to a service and, of course, what that means as well. First up, of course, creating that service. Let's look at how to define our service class, overload the appropriate methods, and get that registered in our app manifest. Now, most of what we've done so far with Xamarin University Android classes has focused on things that we can handle right inside an activity. But there are some things we want our apps to do that might expand beyond the scope of just interacting with a user directly. For instance, maybe we want to connect to a heart rate monitor, and that data could be coming in all along, even when we're not actually looking at an activity. The same is true, of course, of GPS, or maybe we're trying to do things like just save some data, either preferences or maybe some sensitive, again, maybe medical data. And those things could take a little time. And if we've kicked off that process, but then moved on from the activity that kicked off that process, we still want the user data saving, we still want the encryption process to continue. So in all of these situations, we're talking about things that we can't just rely on an activity being around to do. In fact, the way activities work is that of course, they stay around in the back stack, as we've discussed in previous classes. So when I go from activity 1 to activity 2, activity 1 is still there. So we don't necessarily have to worry about that one going away in this particular example. But what about activity 2? When I go back from activity 2 to go to activity 1, activity 2 is in fact destroyed. When I go back from an activity, when I pop off the stack, I actually do destroy the thing that I'm backing out of. So that activity 2 being destroyed means if that one was the one that tried to kick off some work, then I've actually gotten rid of it, and that work could be in an unknown state. It really depends on what we were trying to do, what state that work's going to be in, but we can be certain that it's probably not what we wanted to actually accomplish. And so if we were doing that, we're going to want to come up with a different solution. Maybe activity 2 could, for instance, start a service. And when we talk about services, it's important to remember that our applications are not just made up of activities. Of course, that's the most common building block of an application in Android. Activities are screens, and like any app framework, our screens are really important. But there are, in fact, other things as well. We do have services. These are the long-running things that take place not connected to activities, not directly connected to screens. There are also a couple other things that could be of interest, like broadcast receivers. These things allow us to interact with other applications, to receive information from other applications, other processes, as well as maybe loosely coupled parts of our own application. We can also work with content providers. Now, all of these things represent part of our applications. These are building blocks of our applications. And they do all, in fact, often take place right inside our one app process. It is possible, of course, to have services in a different process, but that's an edge case and not usually something that is actually necessary and does add complexity. So usually our related applications, our related activities and services, and even broadcast receivers will all share a process. Of course, as I mentioned, the service is the thing that's kind of disconnected from our activities. from our user behavior. So it's generally considered headless, though it does have some ability to interact with the user. I'll address that shortly. Independent actually does refer to the fact that it doesn't really care what the user's doing other than a few key API points. So it just operates independent of our activities being created, our activities being destroyed. It doesn't really care. And it tends to be resilient. That is, it's more reliable to stay running than is a single activity. When we mentioned headless just a moment ago, I said that it does have some ability to interact with the user. So it's not as headless as some UI frameworks have in terms of their services or daemons, because we can directly display a toast from our services. We can display a notification. Notifications are actually a specific class that have some specific capabilities. We're going to talk about those later. We can also allow our services and activities to work together. And of course, this tends to be the most powerful because activities can show and interact with the user quite in depth. However, it's also the thing that involves the most work to implement. We're actually going to look at this later on as well. When I say independent, that means that as those activities are created and destroyed, the activities can kick off services, but when the activity is destroyed, the service doesn't mind. The service has its own lifetime, and it tends to be a longer lifetime, or at least a more independent lifetime. When we talk about resiliency, we're referring to the fact that the operating system actually tends to kind of respect services. That is, they're less likely to be killed when our system is under memory pressure. Even when we're low on memory, in which case our operating system will start to actually shut down background apps. It will tend to give preferential treatment to any processes with services running. So our services are less likely to be killed than anything else. So our services can keep on running in the background. The operating system also gives us ways, which we'll talk about shortly, to make sure that our services get restarted even in the unlikely event that they do get forcibly terminated. So let's see a quick demo of the differences between activity-based apps and service-based apps, or really the differences between when we're running a service and when we're not. Here I have an app that is running, and we actually have the code for this in our demo folder in Start 1 resources. So you can check this out if you want, but right now we're actually not going to dive into the code. We'll dive into the code on services later in the class. Right now, let's just look at the behavior of how Android treats services versus non-services. So right now, I do not have a service running. Even though this app has a service in it, the service isn't running. And so what we'll see is the app, even when I leave it open, I don't intentionally close it. If I navigate away from it, and then actually what I'll do is I'll navigate to our developer settings, and we've got a little window here that will show us what apps are running. Open app again, sure. So navigate down to my developer area, and then to running services. And when I go into running services, we can see actually, even though that says running services, it really actually means running processes because it actually shows all of the processes. And the only ones that are running, and by running we mean have CPU time given to them. In other words, are allowed to execute on the CPU. The only ones that are allowed to do that either have services or are the Foreground app, which in this case, of course, is the settings app itself. We can see that our application, even though we didn't do anything to actively close it, is not allowed to be considered running. It's not a running app unless it's either running a service or is the Foreground app. Now we can actually also see cached processes. Cached processes are things that are loaded into memory, but not actually being given any CPU time. And we can see that our Shake to Launch app is included in that. Now, let's go back to our Shake to Launch app and actually start a service. And now, by the way, this service is essentially listening for a shake type gesture. And if we shake the actual device itself, then it's going to launch whatever we configure it to launch. So I've got now my service started, and navigate back and we'll see that according to settings, when I look at running, we're now back on the running, look at that, shake to launch, one process, one service. So this means shake to launch process now is allowed to keep running, is allowed to keep executing on the CPU. Of course, it's the service that's doing so because we have that service. This, of course, also is less likely to be killed, less likely to be terminated in the event of memory pressure than any of the ones that are just cached. So that's demo one. Let's get back to our slides. Let's look at an example service like the one that's in our demo. This one will, when the user shakes the device, launch some application. So if they have camera selected, then shake and the camera launches. Now, of course, in order to do that, we need something running all the time, listening for that shake event. User selects what to launch, that service is paying attention to it, and then, of course, the service then can monitor and launch our actual application. So how do we do this? Well, we're going to, first of all, create a class derived from service, add the service attribute, code our onCreate, code our onStart, code our onDestroy, and then launch our application. Don't worry, we're going to dive deep into each one of these bullet points here. First of all, our class. Our class is going to derive from service, which we see service here has an onCreate, onDestroy. We have an onBind method that we're not going to deal with yet. We'll do that later on. And we have the onStart command. We'll, of course, need to override several of these in order to get our intended behavior. Speaking of intents, our onStart command accepts one. And we, of course, know how intents work because that's the same thing we pass into activities. So we'll be able to pass our arguments to a service through an intent to the onStart command. And then our onStart command accepts a return value of start command result. We'll talk about that momentarily. Notice, by the way, that onBind. I told you we weren't going to deal with this yet, so we're just going to have that be returning null right now. We'll talk a lot more about that later. Here's our example class deriving from service. Now, all of our services, in addition to deriving from the service base class, will have to have a service attribute. That's because in Android, we have the Android manifest XML that tells the operating system everything that's in our app. Well, one of the things that we'll have in that Android manifest is an entry for every single service. Now, going back and forth to the Android manifest XML is a pain. And therefore, what we can do in Xamarin is put an attribute on our class, and then that attribute will be copied by the Xamarin build process into our Android manifest file. And all of the properties that we're setting on that attribute will end up as attributes on our XML. Now, in deciding what code goes in your onCreate and what goes in your start command, there is some subtlety, but onCreate will be called once per service, and it does not get any of the arguments in. So those will be your kind of hints as to what to do in the onCreate. So we can create resources that we'll need to use, and where we don't require any of the intent arguments to have been given to us yet. So we'll set up our onCreate. In this case, we're actually monitoring the accelerometer because we're looking for the shake, of course. And our service is actually receiving the shake callback itself by implementing the appropriate interface. Now our onStart command is up next. Now this, of course, does receive the intent. And this is going to be called whenever any activity calls start for our service. We'll receive an intent, and if any arguments are required, they can be passed in there. Any start command flags that are needed. For instance, if this service was restarted by the operating system, that operating system will tell us with the start command flags, and then we'll get a start ID. This is a unique number that's changed every time onStart command is called. And so remember I said onCreate is only called once per service instance? It turns out onStart command is called once for every time you call service start. So if your activity does that many times for whatever reason, you'll have your onStart command called those many times as well, but you'll get a unique start ID each time. Now our return for onStart command is a start command result. This actually tells Android how to handle the resiliency of this service. So for instance, if we return sticky, that means restart this service if you had to shut it down, Android, because of memory pressure. Again, services are less likely to be stopped because of memory pressure, but it can still happen. If our start command result is sticky, then Android will restart our service. It'll call onStart command again, of course, passing those flags that I mentioned earlier. Not sticky means, well, it just won't. Redeliver intent means it's sticky, and Android will hold on to the original intent that was passed into onStart command, and when it recalls it, when it restarts it, it will pass that intent again. There's also another one for compatibility purposes, sticky compatibility, which acts just like sticky unless you're running on a completely ancient, less than API 5 version of Android, which you're probably not. So then in the body of our onStart command, this is where we're going to want to do most of our work. So here we see that it's actually the client passing in to tell our service what action is going to be fired when we actually receive the shake event. As it turns out, the onStart command actually is fired on the main thread or UI thread of whatever actually called service start, which frankly is usually one of our activities. Our activities, of course, are also responsible for interacting with the screen, interacting with the user. That means if we call onStart command and just do all of our work in a foreground thread, we're actually blocking the UI. So frequently we actually do have to create tasks or background threads to kick off the work that we want the service to do. Now, as it turns out, this example that we're working with here is a little bit unique in that it just registers an operating system listener for that shake event, and then it's done. So it's not actually actively doing any work in a main thread. So for that reason, this one's a bit unique, and we don't need to actually create our own tasks or our own threads. But bear in mind that sometimes you'll need to. You want to receive the onStart command call, and then basically immediately return that start command result. And then in between there, you'll probably maybe kick off a task. And when all is said and done and your app is finished doing its thing, whether because the user stopped it or because it just finished doing whatever it was supposed to do, we'll have an onDestroy. And in onDestroy, we're going to want to clean up, of course, anything that needs to be cleaned up, most notably and most commonly, any event subscriptions, including in this case, our sensor manager. So we'll unregister that listener. And with that, it's actually time for our first individual exercise where we will define a service. And in this exercise, we will only be defining the service. We won't actually kick it off. We won't actually get it started doing any work until our next exercise. Right now, we just want to define it. So we're going to go into our exercise 1, create a service. And we'll see that we need to open our starter solution. So let's go ahead and do that. Get that open. I actually have that open over here. So we've got our starter solution open. Let's take a look. We're actually just creating a very, very simple application here. If I give this a run, you'll see we have an activity with 2 very simple buttons on it. It's going to say start a service, stop a service. And it's actually a pretend download service. We're just going to create a mock download service here. So start and cancel. That's basically all we've got. We're going to define the service that these buttons will eventually interact with right now. So let's go and add. Oh, I need to stop that, don't I? Stop the solution, and then we'll add a class. And this class, I'm just going to name my download service. We're going to have this derive from service, obviously, and that'll mean that we need to implement certain things. Now, this is the only required member, but it turns out this is also one that we don't actually care about just yet. We'll talk about binding later. For right now, we've just got the not implemented exception. We do, however, care about some of the other methods in our service, so let's start overriding those. So override on create. I'm going to override on start command. That is not correct. And we're going to override on destroy. The other thing we're going to want to do is make sure that we can see the stuff happening, since obviously this is for demonstration purposes. So we want to see as all of our methods get called. We're going to do this by just logging everything to our output window. So first let me define a tag that we're going to be using. We'll use that for everything. And then we can just go into each of our methods and log.debug tag and service created here. Or whoops, this is service bound. And I need a using. And then we will just copy and kind of do this for each one of these. All right, so we've now got our rough implementation. Obviously, it's not actually doing any real work yet, and we'll eventually put that into our onStart command. But we've got our rough implementation. The last thing we need to do, we've derived from service. We need to also add that service attribute here so that it can enter itself, so that the build process will enter this service into our Android manifest file. All right, so let's go ahead and give things a build. All right, so our build succeeded. Let's look at the Android manifest file that's actually included in our solution. And we'll notice this is very, very sparse. So what our build process actually does is it takes anything that we put in this Android manifest file and it merges it with all of the attributes that we have for, say, activities and, of course, services. So in our actual build directory, we have the final Android manifest that has everything. Let's go ahead and check that out. Open containing folder for our source, and we're going to navigate to our obj debug, then under our Android here. So this is the actual output of our build process, and now this Android manifest file looks quite a bit more fleshed out. Even for our simple application, we see that there's a lot more to it, including now a service. And that's how Android knows that our app actually includes a service, because the operating system will be reading the Android manifest file when we install, when we launch our application. The Android manifest file is what tells our operating system all about our app. All right, so let's learn how we're going to launch our app by getting back into our slide deck. So in this section, we learned how to define our service, how to override the appropriate methods, and how to get it registered in the app manifest. Next up, we're going to learn how to actually start that service, get it doing its thing from the client's perspective. We already know how to override the onStart command from the service's perspective, but now we're going to see how to bring it all together, have a client start the service, and have them work together. So starting and stopping a service are the most simple ways we can work together. And so that's what we're going to start with. So for this next section, let's talk through a couple different examples. One, downloading a large piece of data, doing it on a background service to be sure that it continues even if we navigate away from whatever the appropriate or applicable activities are, and playing music even when our app isn't in the foreground. We're going to actually talk through these as something called a started service. A started service is differentiated by the fact that we explicitly call start on it. Some activity will explicitly call service.start, or start service actually is the name of the command, start service. Now, when that happens, we will, of course, start the service. Some activity calls that and we start the service. There is actually another type of service called a bound service that we're going to talk about later. So when we say started service, we're explicitly referring to something that was started with the start service call. These then can go on doing whatever work they need to do, and they'll be stopped when either some activity calls stop service, like this, or when they call stop self. So of course, the music service is supposed to just play whatever music we have playing until the user's done with it. So it's the user's job to call stop, right? On the other hand, a download service knows it's done when that file is downloaded. So when the file is done downloading, it'll call stop self. Either way, we're basically telling the operating system, this service is done, you can call on destroy and clean up its resources. Of course, as we know, we can pass data into our started services with an intent. So we'll call start service with an intent. This, of course, gets passed to that onStart command that we looked at earlier. And the service can then do its work, like, for instance, downloading data and saving it to the file system. One thing services will frequently do when they are finished doing their work, or maybe even as a progress report, is send out broadcast notifications. And in order to receive these, our client app would have to implement a broadcast receiver, and it would go and register to look for specific types of messages. When those messages were received, and they get routed through the operating system, when those messages are received, then the broadcast receiver typically will notify some activity that can then display some information. Now, we're not going to dive deeply into broadcast receivers today at all. However, I do have an example available in one of our exercises. So if you want to check that out, you can actually see that in Part 2 resources, we have a bonus version of our exercise that does have a broadcast receiver implemented. More information on broadcast receivers implemented with Xamarin at, of course, our docs. Now remember I mentioned earlier that our onCreate is going to end up being called once, period. And that's because you can only ever have one instance of a given service on your Android device at any one time. So no matter how many times we call start, it's going to be talking to the very same instance. And once it's created, it's created. That's why onCreate is only called once. However, each one of these calls to start will, as I mentioned, cause our onStart command to be invoked again. Now, how do we start, by the way? I mentioned that the name of the method is start service, and this is actually on our context, meaning all of our activities have built right into them, because activities derive from context, they have what's necessary to call start service. So we can usually just, from our activities, call this.start service, pass an intent that has the type of service we want started. We can also call stop service in the example like the music app where we want to have the user or activity have control over stopping. Or of course, services can be stopped with stop self, which is available on the service if they know that they're done, like the example of downloading where the service itself is what knows that, okay, the file is completely downloaded. Here's an example of calling start service from an activity. Create our intent. Of course, the intent needs a context. That in this case will simply be our this. Pass a type. That's the service we want started. And then we can call start service. Now, if I pass this here, I could also say this.start service, or if context is a context, that could also be context there. So that would actually, that's actually something we could do either way. This and context here in this slide both represent a context. And of course, the service accepts that intent. Stopping a service, as I've mentioned, is as simple as calling stop service on the context. Notice it too takes an intent, and it needs the intent to have the type that you want stopped. It does not, however, have to be the same instance of the intent that started the service. Just needs to have the type. And when you call stop service, that will cause that service to stop, of course. And finally, as mentioned, stop self is something that the service can do when it knows it's done. Here's what this looks like in kind of a flow chart. We can call start service to start our started services. OnCreate will be called. OnStart command will be called. Should this be called multiple times, then this would be called multiple times. But OnCreate would not because we're in a singleton. Our service is, of course, doing whatever OnStart command told it to do, doing its work. And then our service gets stopped either externally by a call to stop service or internally by a call to stop self. And then the operating system, Android, will actually fire the onDestroy event for us. And that brings us to our next exercise where we're going to start our service. All right, so let's take a look here. We're in exercise 2, entitled Start a Service, even though we're going to actually do more than that. We'll, of course, be continuing from the previous exercise, as I mentioned before. Let's go ahead and start with our main activity. In our Start button, we're going to go ahead and create an intent, and then call Start Service with that intent. And start service. Whoops, that did not enter the correct type there. I want a new intent, which I am going to need a using for. There we go. Now the code compiles. All right, and then for our cancel button, this is where we'll actually stop the service. So now we don't, of course, need to use the same instance of the intent or anything like that, so that'll work just fine. As long as we can tell Android that it is this type, we need to be stopping, because of course there's only one service ever. So if I've started it, then I want to stop it. Any service instance, there will only be one service instance. So any service instance of this type needs to be stopped when I call stop service. All right, and that means we can switch over to the service itself and actually start doing some work. First, let's just have it give us a little bit of a UI, a little bit of feedback here. So I'll say toast.makeText. And that'll just put something on the screen to let the user know that, in fact, the service has started. Now what I'm going to do is go ahead and simulate my download service. So we're just going to create a loop here for a given number of steps. We'll eventually parameterize the number of steps, and we'll sleep as we loop. So this will just allow us to simulate that we're doing some work for some fixed amount of time. Some work happening in the background for some amount of time. This will just give us some information to feed back to the user, this %done. So we'll just base this on a little math on the number of steps we're doing compared to where we are in our loop. and we will log debug this information. Thread is going to want to using. It's the .NET thread that we want. Whoops, I actually need an equal sign up there, don't I? There we go. So now we've got that loop that we're just going to go through, and we're going to sleep. Pretend we're doing some work. This will just give us a fixed amount of time here, about 7.5 seconds, according to sleeping for 500 milliseconds and 15 total steps. So for 7.5 seconds, our service is going to do some work. This is what we're simulating. And then we're going to say, all right, we need to, of course, return that start command result. And so we'll say start command result dot redeliver intent. So that's our sticky plus resend that exact same intent. Now, in theory, this kind of looks okay at first, assuming that we were actually doing some real work there. We'll ignore the part about it being fake work for right now. But as we learned in our slides, this really isn't okay yet. We're actually doing everything right now on the UI thread or on the main thread because our main activity is actually in the same process with our service. And so when we call start service, Android is just going to come in right on that main thread and start executing this code. Furthermore, if we're going to be doing our service right there in line, we're never really going to be able to give Android the answer on what to do in the case of having to restart the servers. So we obviously need to return this instantly, and we need this all to be on a background thread. So let's go ahead and create a task to handle that. We'll just indent everything in the for loop. This is really the meat of the work here. And then task.run. Again, we need that using there, so let me get that in place. And close everything up here. Now, the one other thing we're going to need to do, now that we're doing this in a background thread, Android doesn't really have any way of knowing when we finished doing our work. So we have to tell Android, hey, we finished doing any work that the service was responsible for, so you can now deallocate the service. You can now garbage collect the service. And we can do that by calling stop_self. This will in turn actually cause our onDestroy to be called. That's Android's responsibility. We just need to tell Android that it's been done. Stop_self will handle that. Now, interestingly, this handles the stop_self scenario, but we haven't yet handled the stop_service scenario. That is an external command saying, hey, service, just shut yourself down. We are going to do that, but we haven't yet. That is to say, this will just keep doing its thing because we've kicked it off in a background thread. It's just going to keep running. Nothing's monitoring it. Nothing's canceling it yet. So even when that cancel command comes in from here, when we call stop_service, sure, Android will call the onDestroy, but we're not actually going to stop doing our background work here until Android actually decides to garbage collect everything. Then sure, eventually it'll be forcibly killed, but that'll actually be fairly graceless. We want to actually make sure it happens exactly when we call stop service, and we want to make sure we have a chance to do it gracefully. First though, let's actually do some parameterization. Right now, we've got this hard-coded in our service. We're going to pass this from the activity instead, however. We pass data to services just the same way as we do in activity. So where I have my intent here, I can just do an intent.putExtra. And now that's going to make its way to the service. So let's go over to the service and consume that information. Now my steps can be intent. Of course, the intent comes right in on the start command. There it is right there. So I can say get int extra. And we'll provide a default just in case it couldn't find the int extra. All right, now it's going to actually loop for as long as that parameter tells it. This is actually a good time for us to do a demo, so let's go ahead and hit start. See what we've got so far. All right, so start download. There's our toast. Download started. And so it'll do its thing. We can actually go ahead and watch this in our output window because we have all of those debug write lines, and we can see that it worked its way through, and then service destroyed was called right there. So after calling stop_self, we eventually got to that service destroyed. As I mentioned, now if I hit start download here and then quickly hit cancel, this is going to cause stop service to be called as we know. But let's see what actually happens. So start download, cancel download. So it's going to be kind of interesting. Notice download started, and then it says service destroyed. So service destroyed is corresponding with me calling stop service, but it didn't actually stop the work, did it? The work kept happening in the background because it's just a background thread. So we're going to have to actually handle that ourselves. Now, depending on how you've implemented your task, that you could, for instance, use a cancellation token. In fact, in a lot of cases where there's real work involved, you're either going to have to, or it's going to be by far the better way to do it. We'll do it a little bit more brute force here right now, just to get it done. However, often a cancellation token source is going to be the best approach. I'm going to start by creating a couple variables for us to use to track our running state. I'm going to make these volatile because we're going to be accessing them through multiple threads. Now remember, volatile doesn't automatically make them thread safe. It just means that our compiler optimizations won't prevent us from actually respecting the variables. For more on what the heck I'm talking about here, check out our CSC 35X classes. There, I'll be more than happy to dive very deep on the topic of volatile and all sorts of other threading techniques. So right now, we'll just stick with declaring them. So a volatile bool is canceled and is downloaded. Now, every time we come into onStart command, I'm going to set those to false, because we're kind of starting the process over each time we call onStart command, right? Now, things get a little complicated because the only way my service knows that the stop service button, or that stop button was called and that stop service was called, the only way my service knows that is because onDestroy gets called. But onDestroy also gets called when we call stop self. This is actually why we needed a couple bools to help us keep track of where things are at. So what we're going to do is, whenever onDestroy is called, we're going to call isCanceled equals false. We're going to set isCanceled to be false. Or to be true, rather. True. We're going to set isCanceled to be true. And now we're going to say we'll shortcut any work that's happening. And again, this is where a cancellation token source might come in handy, but for our loop, it actually is pretty easy. We'll just say we'll only continue if isCanceled is false. Now this, of course, short circuits our work, but then once our work gets short-circuited, once our loop stops, we're going to end up calling stop self. We don't really want to call stop self at this point because onDestroy has already been called. We already went through that routine, right? So we actually need to only call stop self if the loop finished naturally. So if isCanceled equals false, or if not isCanceled if you prefer. And we'll set isDownloaded to true. That means that it succeeded. And then we would call stop self. Now what we can do is we can finish working our way through our onDestroy. In addition to setting isCanceled equal to true, which this one, it doesn't matter if we came in here through stop self. We'll end up setting isCanceled to true, but then it'll be ignored, so it's fine. And now I just want to show some toast telling the user whether or not downloaded succeed. And we'll just copy our toast code and change our status to complete or canceled. And now it's time to demo. Let's hit play. And check out our output window here. So now when I hit start download, of course, and don't do anything, we'll see it work its way through the progress. Looks good. And then we saw the toast come up that said it was done, so that was good too. We saw the success toast. Now let's hit start and cancel. Quickly hit start and then cancel, so we see service started. We see some progress, and then we saw service destroyed because I had gone ahead and hit cancel, which short-circuited our loop over here. So let's actually watch the emulator as well and see the toasts that come up. There's our download canceled right there. If I just let it go through, we'll see download started, and then after a little while, download completed instead of canceled. All right, so right now we're interacting with the user exclusively through these toasts. Turns out there is a more interesting way we can use called broadcast receivers. Now, it's a little bit outside the scope of this class, but we do have a bonus exercise that takes advantage of those. So feel free to open up the Part 2 Resources bonus solution and take a look through it in depth. I'll give you a quick cursory look at it right now. So in this slightly modified version, what we have is in our main activity, there's now a progress bar. That progress bar is just going to kind of show general progress, not actual percent complete or anything like that. It'll just show work being done. And when we learn from the service that the work is no longer being done, that is, that we've actually completed the download, then we're going to stop showing the progress bar. So the way this works is we create a broadcast receiver in our activity, and then our service will be broadcasting. So the receiver, we actually need to create some class. So download receiver, I have here, basically is just there to receive. So it derives from broadcast receiver, and it's going to get some information. This is very similar to .NET events. This is just a way that it's being handled, that kind of global events are handled within Android. So these can be events that are more throughout the entire operating system. So we can see that we're having our receive. This basically means some event occurred. When we get that, we can check the receive intent. So just like everything else in Android, we get our information through intents, and then we can see, okay, what happened? As you can see, if it's a download complete, we're going to invoke our event. And so we just define an event right here in our receiver, and our activity can respond to that event, and does in fact respond to that event. So we create an instance of the receiver, we subscribe to the event in the receiver, and then we use our register receiver. This is just a method that's on our base class, so register receiver. And now we've told Android that anytime we see a broadcast for download Silver's filter, you see we provide the filter right there, anytime we get that broadcast, we should inform this receiver. Of course, that receiver will raise the event, and then our activities receiver download complete will fire, which sets our progress bar to no longer have that indeterminate or loading sort of visualization. In my service, you can see that when we complete successfully, we're going to send that broadcast message. So let's go ahead and take a look. And by the way, if we stop it in a non-service way, obviously that means we're stopping it through the stop button. Well, then we don't need the whole broadcast thing to stop the progress bar. The activity can just do that. As you can see, if we just pop over to activity, and you can see that the cancel button just also tells the progress bar to stop. Okay, so our service, when it succeeds, will send the broadcast message, and then our broadcast receiver will fire the event. All right, start. There's our progress bar up top there. And when it completes, our progress bar is able to stop. All right, now let's get back to our slides. All right, in this section, we saw how to start a service and how to stop that service. Now we're going to look at how to elevate a service to the foreground. First, that means how to elevate it to the foreground, how to build up a notification, update that notification, launch our activity from that notification, and then remove the service from the foreground. Now we'll talk about what all of this means as we go through this section. You'll understand each of those bullet points by the time we finish. Now, why do we need to elevate things to the foreground? What does that really mean? Well, again, we have to go back to talking about how Android can terminate certain apps when it's under memory pressure. Now, it does try to avoid terminating services. It will first terminate other background applications, and then only if there's really, really bad memory pressure will it terminate any running services. But eventually, it still might. However, we can register our services to be even less likely to be terminated by calling ourselves foreground services. Now, foreground services are things that will impact the user even though they're considered to be in the background. For instance, I might have a Skype call running. If I'm in the middle of a Skype call, even though Skype isn't my foreground app, it's still kind of a foreground service. It's still something that I, the user, am aware of. Same thing with playing music. So anything that is going to directly impact the user is a candidate to call a foreground service. Now, a foreground service has to generally explicitly opt in, basically elevate itself to being a foreground service by calling start foreground. And because it's a requirement that this is something that the user is aware of and interacting with, that's kind of the point, that means that start foreground requires us to pass a notification. In other words, even if we're not otherwise doing something that the user is aware of, they're going to be aware of us calling start foreground because we're passing a notification. Now, we can also see that there's a stop foreground as well, and we can determine whether or not we're going to remove the notification when we de-elevate ourselves, when we de-escalate ourselves back down to non-foreground mode. But what is this notification? Now, notifications can actually take several forms: sound or vibration, make the device obviously vibrate or play a noise, we can have a visual notification. You like how my slides actually play along with the vibrations and flashing. Or we can have a status bar icon. Now, the status bar icon actually is something we need. This is a requirement for our foreground services. Notifications can be built through a notification factory. So you can see we have this notification builder, and then we have this Fluent API where I can set the title, set the text, the icon, and then we'll call build to get the actual notification object. Now my service can call start foreground, pass that notification object, as well as a notification ID. Now we're going to need this notification ID later, because if we want our notification to change at all, maybe our status, whatever our service is doing, the status has changed. So we may want to have the notification have some different information. Well, by holding on to that notification ID, you'll see that we can actually update that notification. In other words, we don't need to just keep stacking notifications into the user's notification area. We can update one so that old information is no longer visible. By updating it, our updated notification, any new text or new titles will just overwrite the old one that was created under that same identifier. We will, once again, when we're updating, use our factory to build the notification. We'll get our notification manager by calling getSystemService and letting it know that it's the notification service we're interested in. And then, of course, when we call notify again with that same ID, we're just updating rather than creating a new notification. Now, it's all well and good to show the user a notification and let them know what's going on, but very often what a user is going to intuitively do is tap that notification. Now, by default, what's going to happen when the user taps the notification, it's actually going to go to the settings for your app. Not even to your app, but to the settings for your app, which is probably not very useful. We can do better by using a pending intent. A pending intent is something that's going to wrap an intent, and of course an intent is something we can use to say what we intend to launch. Well, what we intend is to have a certain activity launched when the user taps the notification. The way we'll do this, create our regular intent saying what activity we intend to have launched. Again, wrap it in a pending intent. We can say pending intent get activity, passing the intent that we want, the intent that has the activity we want. And then, by the way, we do have other factory methods available in our pending intent. This is one example, a common one. And then we can set this pending intent inside that notification. So this is our notification Fluent API again, where we set the title, icon, etc. Here, we're now also including our pending intent. And so this means that when that notification is tapped, we're going to launch that activity. And eventually, our service no longer is interested in being a foreground service, so it can return to normal service priority by calling stop foreground. If we want the notification to go away from the status bar now that we're no longer a foreground service, we can include true there. If, since the service is still running, we want to leave the notification, we certainly can by simply passing false. And that, guys, brings us to our next exercise. Let's elevate our service to a foreground service. Okay, so remember, in order to elevate our service to the foreground, we need to have a notification to show the user that our service is there. That is a requirement of a elevated service. So first thing I'm going to do is create my notification, or actually create a helper method that will help me get a notification. So let's go ahead and do that right here at the bottom of our class. Actually, that's the bottom of my namespace. Let's get that inside the class if we want it to work. And then we'll be using our Fluent API. We'll get first our factory, so notification.builder, a new notification.builder, and then start providing builder parameters. We'll need an icon to show up at the top of the screen. And then we can build to get the actual notification instance. Now that we have the ability to get a notification easily, what we'll do is go to where our start command is invoked, and we will immediately elevate the service when we start downloading. Start foreground. We're going to need to provide a notification ID here. So that notification ID is going to be what we'll use to correlate with our updates later, so that when we update this notification, we actually change the text of the notification on the Android notification area, basically here. We want to change the text of our notification when it comes in, rather than just continually creating new notifications. The way we do this is by making sure we always use the same notification ID. So I'm going to create a number that I will use for my notification ID. It really doesn't matter what we use here as long as we keep updating using the same number. So now that I've got that, I'll just put that in here, notification ID, and then we need the notification itself, so I will use my helper method. Now, as our task runs, as we actually do the work, we're going to update that notification to let the user be able to check in on the notification up there and see what the latest and greatest information is. So let's go ahead and now create another helper method that will update our notifications. This one will take advantage, as a matter of fact, of getNotification itself, and it will be called update notification. It will, as I said, take advantage of its sibling method right there. We have a notification now with our updated content, or at least we will when we're actually calling this update notification method. Now, in order to actually tell Android that we have this new notification, or this new information for the notification ID that we already established, we have to get a reference to our global notification service. So we'll call get system service, and then we'll pass which service we want a reference to. That's the notification service. Now, in order to actually call notification service methods on this, we'll have to cast it. So let's do that. And then we'll assign all this to a variable. Finally, using this, I can say notification manager dot notify, and here, critically, for my parameter notification ID, I will, of course, there it is, notification ID, I will, of course, be providing the same one that I used before. That variable that I created, that const that I created, now it's going to update that with my latest content. That, of course, should be the notification that we got from our get notification there. Let's go now back up to my start, and inside the loop, let's update this to call update notification. All right, let's go ahead and check things out so far. What do we have? And so now when I click start download, we're going to see something show up in the notification area. And then if I click that, we'll be able to watch it update real time, just like we see the percentages showing up in our output window. We're now seeing it in the actual interface of the app. So start, click that, and you can see that percentage updating. Now, however, the thing is, if I manage to click that percentage in its card, because we are actually finishing a little fast, let's see if I can click that. No, I can't. What we're going to do in order to do this demo, I'm going to actually make that last a little bit longer, so, or maybe a lot longer. Let's just change that to something crazy like 70 so that it runs for a good long time. And then we're going to see that clicking that doesn't do anything useful yet. And we need to do some work in order to make it do something useful. Start. Let's get that notification on the screen. And then click it. And we get nothing. So let's change that. Let's go up to our onCreate and create a pending intent. So we're doing it in onCreate to make sure that anytime this service is around, so is the pending intent. Actually, let's declare it first up here. And then create it down here. Now we want to say that we're going to launch our main activity whenever this pending intent is initialized. So first we have to provide our context. Request code doesn't really matter in this case. Now we embed a regular intent inside our pending intent, which again needs our context. And then here is where we give the type that we want launched. So we're going to want a main activity. Now what we do with this pending intent is to provide it to our notification. So let's go down to our get notification, and anytime we create one of these notifications, we're going to provide it the intent. That means that anytime a notification that came through this method is clicked, it's going to launch that pending intent, which is of course associated with our main activity. So in other words, clicking a notification from our app will launch the main activity of our app. It could be any activity, but our app only has one activity. So now let's check things out. This of course is more like what we would usually intend. You see something in the notification area for some app, so you click that notification, and then it's going to take you to the app. So let's hit start. Then I'm going to get this out of the way so that we can see it actually launch when the time comes. And there we have it. All right, so that's it for this exercise. Back to the slides. All right, we've seen how to elevate our service to being a foreground service, how to build up our notification, update that notification, how to launch an activity when the user taps on that notification, and finally how to demote our service back to a non-foreground service. Next up, we look at binding to a service and how this differs from what we called a started service earlier. So in this section, we'll talk about what is a service binder, what is a service connection, how to use those to bind to a service, how to respond to our notifications, and then what are hybrid services. These are going to be a hybrid of these bound services and started services, and we'll talk about how those have a particular advantage. So why talk about bound services at all? What is the advantage that we're getting out of these bound services? Well, sometimes those notifications that we talked about getting from our started services just isn't enough. Sometimes we need more interactivity with our service. Of course, you could think about a music playing app where we want to change tracks or change volume, etc. We need more interactivity than we would get out of just sending a notification or just stopping self. Or maybe we can talk about a fitness app, that heart rate monitor. We want to actually see the heart rate going up, going down. Maybe we want to change the sample rate, something like that. So anytime we need really, really rich interactivity with the service, we want our activities to be able to bind to the service, and then they can issue commands or respond to events. And so a bound service is a service that exposes the necessary endpoints to allow our activity to interact with it, to issue those commands, to respond to those events. And the reason a bound service is not a started service is because the lifetime of a bound service is actually dictated by who's binding it. So for instance, when one activity binds to the service, it's also going to start that service. That first activity to bind, that first client to bind, will in fact start the service. If another one comes along and binds, well, it's just going to connect to the currently running service, and now they both have a handle to the service. When one unbinds, no problem. As long as there's at least one client still bound to the service, then the service continues to run. But when the last client unbinds, that is, when there's no more clients connected, the service will actually stop. And of course, this is very different from a started service. A started service, once we call start, it just keeps going, regardless of whether or not anyone cares. It just keeps going until either stop self or stop service is called on that service. With a bound service, you must have a connected client. You must have something connected. And as soon as the last one unbinds, the service will stop. Now, this whole process actually has some added complexity in that Android has this whole system set up to allow for inter-process communication. That is, to allow for a service and the activity that acts as its client to be in two separate processes. It turns out that we don't actually use that often. The majority of the time, our service and our activities that want to connect to it are actually in the same process. But this infrastructure has made things fairly complex even when we run in the same process. With that in mind, we can see that there's actually several steps involved. And again, it's because of this IPC business, this inter-process communication business. There's actually several steps involved in getting our client connected to a service. Not just several steps, but several classes, several types that we need. We can see we have the I service connection, we have the I binder involved, and we have code written on both the service and the client in order to facilitate this connection. And it can be rather confusing and overwhelming, all the code necessary to do some relatively simple things. So at this point, I always like to introduce a metaphor for everyone that some people find helpful and some people may find silly. But I want you to picture an electric guitar and an amplifier. Now, the electric guitar we'll think of as our service. It has some data that our amplifier wants to use. And our amplifier will be our app or our client or our activity. And the amp is going to use the data because it's going to, of course, play it really loudly. So the guitar has data and the amp wants the data. It's the client. But they can't just magically speak together, right? They don't just magically transfer data between them. Instead, the guitar has a plug and the amp has a port. And so those are going to be our metaphors for connecting our service and our app and our client code, the activity. So our service has a piece that it needs to help communicate. That's the plug. And the amp has the port, right? We're going to see that we have some analogs in our service to activity communication. So our activity here, this is what wants to talk to the service. It's going to do so through a binder. And this binder, that's going to be our plug. It's owned by the service side of things. So the service owns the binder. And in fact, it uses the binder as something of a proxy. Again, this has to do with our whole inter-process communication complexity. So our binder is set up as the proxy, the thing that's going to decide exactly what access is given to the service to the outside world. So the activity needs to get a reference to that binder. Now again, that binder, set up with all the complexity in the world. Now the most interesting part of the binder is probably this transact method. This is the part that actually is, if you will, the remote procedure call. It's got this parcel and this reply parcel. This basically represents your input parameters and your return. And so this is the part that basically needs to be very simple data that's going to be serialized and sent over the wire, or sent across processes, I suppose. We don't really need to understand all this in depth. The point is, it's set up to facilitate some very complex, secure code. And it acts as a proxy. It acts as the thing that is kind of the firewall to the service. Now, we don't even usually implement iBinder directly. We'll actually usually have a class of our own that derives from the binder base class. That way, we don't need to think about all those methods like transact. We're just going to implement the actual methods we care about and let the base class handle all that IPC business for us. Usually, what we'll do in our implementation of the binder class is actually accept a reference to the service itself. At this point, if we don't have a lot to worry about in terms of secure access, then we can simply have the binder expose the service itself as a public property. If you want, you can set up access methods to allow for certain rights and things like that, but it's usually unnecessary if we're talking about in-process communication, which is what we're going to be talking about most of the time and what all we deal with in this class. So most of the time, our binder will simply give access to, you can see we accept it as an input parameter to our constructor, and then we just set the public property. So binder is just a way to get to the service, basically. And then in the service itself, we have an onBind method we need to override. We actually looked at that earlier, but we quickly said we'll talk about it later. Well, now is later. So now we're talking about it. Notice that in our onBind of our service, we are required to return an iBinder. And so we'll instantiate our custom binder, passing a reference to the class, to the service, because of course we said that our binder is going to just do nothing except really expose a property of the service. So it's kind of a very simple wrapper in our implementation because we don't need to worry about all that IPC stuff. So we just pass our new custom binder. So at this point, we have our service and we have its binder, its proxy, its plug. So this is our guitar and this is the plug. So our server end, our service, is complete, right? It's now got a way to connect and a thing that does the work. So now we need our client. Our client is going to be some activity, and it's going to want to connect to the service. Again, bearing in mind that this is set up for potential cross-process communication. And so for that reason, amongst others, attempting to connect to a service is an asynchronous process, and it's done using callbacks. The callbacks in this particular case actually take place on a separate class. It's going to be delegated the responsibility for dealing with all of those events. That separate class becomes the port that the plug wants to work with. So our activity ultimately needs access to our service and its plug, and it's going to get that access through its own port, if you will. And again, this is a metaphor. There's no actual terminology port involved. In fact, what we have is a service connection object. So our activity will end up using something called a service connection that will want to interact with that binder. Notice right here, our activity derives from context, and it has this bind service. And it's here where we'll specify what service we want to connect to and where the callbacks should come in. So that's our service connection right there. So right here, our activity, when it wants to interact with a service, will say, I wish to interact with this service. Notice it's done through an intent. And it will say, I want the callbacks to come in on this service connection. And again, in our metaphor, the service connection is going to be the port on our amplifier, right? And of course, our activity itself is the amplifier, is the client. Now, this being an asynchronous method, the true-false return value we get there is probably less important than it seems. So getting a true doesn't necessarily mean we have achieved a connection. You'll get the true right away. We're actually going to be looking for these connection callbacks here to really know that everything worked. And so in that iService connection, we'll get an on-service connected callback once everything comes together. And what we usually expect then will be that my activity is going to call bind service. It's going to pass an instance of iService connection. So the activity that calls bind service typically will go ahead and instantiate its own service connection object. And it will send a type of service. In that intent, it's just going to send a type. Then Android will decide, okay, I'll instantiate the service or I'll find an already existing instance of the service. When it finds it, it will use that onBind on the service to get the iBinder. Remember, the service is going to return a binder. Then Android is going to call on our service connection. It's going to call the onService connected, and it's going to pass that binder in. So now our service connection has a reference to the binder, which has a public property with a reference to the service. So now my service connection has a reference to the service. So let's look at the code. Here I have that onService connected callback. We pass in that iBinder, or rather Android passes in that iBinder. And since that's just iBinder, we're going to have to actually cast that in order to then look at that public property we created. So we know that this is castable as our custom binder type. Then we can grab the service, that public property we created. So now our service connection has that. Maybe our service connection itself could expose that. And so here's that call in the activity where we're actually binding the service. The intent just has the type of service. We create the service connection. The activity has the service connection. It owns the service connection. Remember, we're saying that that's the port on the client. So the client owns this. It just interacts with the binder. The binder is part of the service. The service connection is part of the client. So our call to bind service here will pass that service connection, basically saying, this is where I want the callbacks to come in. It will pass the intent saying, this is the type of service I'm interested in finding and connecting to. And for local services, that is services that are in the same process, we're always going to actually call bind.autocreate, meaning automatically create the service if it's not already running. There are more complicated options for IPC calls, for inter-process communication, but for local ones, we'll always use this, and we'll leave it at that for now. So again, to review the lifecycle, our bind service will either cause a service to be created, or if it's already created, we'll skip to the onBind. Either way, our onBind callback is going to return to Android, is going to return a binder object. That binder object will end up being sent to our service connection, and then our service will go ahead and continue running until the last client, all of the clients, have called unbind. When that happens, we will first have our on unbind, and then our on destroy lifecycle methods called on the service, and then the service will be done. Now, of course, this has some limitations. This means that we cannot have a service always running, but then connect to it when we want to interact with it. Not using this technique, we can't. We'll talk in our next section about how we can do exactly that. But first, it's time for our next individual exercise, binding to a service. For this exercise, we've got a new start solution. So go ahead and get to your Part 4 resources, start folder, and open up that solution. I've got that open already right here. This has its own service in here, a location service. And this location service will proxy some location updates for us. As you can see, it's going to use this location helper, and location helper will actually go through the Android system service location manager to get the updates. We'll expose then those location updates as a service ourselves, where we can actually manage this a little bit better. It also, of course, just provides for a nice demo. But in order to get access to this service, we're going to need to bind to it. You'll notice that there is no onStart command for this one. This one is going to start when we bind. So we actually need to set that up ourselves, meaning we're going to need to return a binder. So let's actually start with that, creating our location service binder. Remember, in our metaphor, this is going to act like the plug that the service needs in order to interface with any kind of client. So our binder is the plug, and our service here has a method that will return the plug, so that when Android needs to, and I guess Android Connect is the roadie in our metaphor where we have a guitar and an amp. So when Android needs to get the plug for this service, needs a way to interact with this service, it will call onBind looking for that iBinder. We're going to, of course, be responsible for providing that iBinder. So we're going to add new item here, and we'll simply say class location service binder. Now this will derive from binder. We'll of course need to then implement the binder methods here, and really it's actually just the constructor that we're concerned with. We're going to accept an argument of type location service because we're going to use this binder just as a very, very, very naive proxy into our service. It's just that a iBinder is a requirement of doing this bind. So we've got our service here, and now we're going to create a public property based on that. And we'll just call that location service, or actually really just service is probably even better in this case to avoid confusion, and set our service to our service, to the lowercase service that came in here on the parameter. Now what that means is if you get a reference to the binder, well, you just call binder.service and you have a reference to the location service. And of course, it's simply the way Android works that we have to use the binder to get access. So we've got our plug. Let's make sure that when Android finds this service and says, hey, give me your plug, we can actually make that happen. So return new location service binder is what we're going to do here. And it will actually just pass a reference to itself because the location service binder wants a location service. Now we have service and plug interacting, they're connected to each other. Great, that's the service side of things. Now we're going to start handling the client side of things. So come in here, add new item, our class, and this will be our location service connection. Remember, this is essentially our port in the client. So this is our client side of things. This is the piece that the client will use, that our activity ultimately will be using in order to interact with the binder and the service. So location service connection. Now, this will need to derive from Java Lang object and need to implement iService connection. Now, implementing iService connection is going to have some requirements here, so we'll just let those be filled out. See, we have our onService connected, which of course is passing in that binder. So now we're able to then proxy that through yet again. Of course, the binder exposes the service. We know that our binder.service is our location service. We're actually just going to pass that on through. So let's have our service connection fire an event whenever we get connected. Let's define that event over here. And then as long as we have a subscriber, we can fire the event. Question mark dot just ensures that we have a subscriber, that it's not a null subscription before we try to fire it. And here, this true parameter says that, yes, it's true that we have a connection. And so that might give you a hint as to what we're going to do down here in onService disconnected, which is say false. So we had a service connection change, and here the parameter is just telling us that we are disconnected, that it's false that we're now connected. Now, since the location service connection itself is still just part of the plumbing, it's still just part of the plug and port system that actually gets the conversation happening, it's not really the thing that needs the service, it too, just like the binder, is going to pass along a reference to the service. So once again, let's create a property of type location service. And we'll of course set that property when we are connected. So we'll have to come in here and after invoking, or actually probably before invoking, we'll have to do it before just to make sure that anyone handling this, anyone subscribing to this, can count on all of the properties already being set. Now, I'll need to actually cast my iBinder as it comes in order to access any of my specific location service binder properties, obviously. So let's go ahead and do that. Var myBinder equals our service. It's called service as a parameter, but we know that it's actually the binder as location service binder. Now that it's cast specifically, I can actually go ahead and set my service equal to myBinder.service, which is the property we created on our binder before. And then of course, our event will be invoked. Now, it's also a good idea when we're doing our casts anytime like this to go ahead and check if the cast failed. Now, in this case, if your cast fails, you've actually got much bigger problems, but it's always a best practice to check your casts. Of course, when our service is disconnected, we'll also want to set our service property then to null because it'll otherwise be an invalid reference there. And now we can implement our actual client. So we're going to get over to our location activity here. And this will actually be the AMP in our metaphor, right? This is the thing that's going to use the LS connection, that location service connection, in order to plug in and consume our service. So first thing we're going to need to do here is have a location service connection. So let's just declare that as a field. And then create it in our onCreate. Now, we have no reason to be bound to the service when our activity is not visible. The whole point of binding to a service is to be able to show the user things about the service. So we don't need to be bound if we're not actually visible ourselves. So in our onPause, we'll unbind, and in our resume, we'll handle the binding. So create our intent for binding. and call bind service. We'll provide that ls connection here, and of course bind.autocreate. Let's fix that method name right there. Bind service is what it actually is. And so now we've got that binding, and our on pause will unbind using, of course, the same ls connection. Now, to review then, what we have happening here is when our location activity is brought on screen in our onResume, we're going to call bind service. We're going to pass that intent, and again, it's Android's job to decide if it can find an existing instance of location service or if it needs to instantiate location service. We really don't care. We just pass the type. Android worries about that. Then Android will have to get a iBinder from that service, and when Android handles that, Android being our roadie, Android will plug in our AMP and our instrument. So it does that, right, by taking the iBinder it got here and providing it to that ls connection, that location service connection. And here we can see ourselves getting plugged in right here. Once we've gotten plugged in, that service, that iBinder, will provide us access to the actual service, the location service. And we fire an event. Our location service connection fires an event. So obviously what we need to do now is handle this event. Let's go back to our location activity. And in that onCreate, let's subscribe to the ls connections event. I'm going to change this parameter to something more useful and more meaningful, is connected. And so then what we're going to do is, if we are connected, if the event was fired because we got a new connection, then we're actually going to end up subscribing to yet another event, because our ls connection, which gives us access to the service via the binder, well, the service exposes the location changed event. And that's what we're really ultimately interested in here. We want to put information about what the current GPS location is on screen. Placeholder method right there will work for right now. And then let's just update our start text. This is the text view we have on screen. And of course, there is another scenario where our event gets fired, and that's where we've lost a connection. So if not connected, then we're going to unsubscribe from that location changed event. And at long last, we can actually update our UI. Come in here, and we've got a few text boxes to update. Just pull that data in right here. The location changed event will have the location, and then we'll just set all those text boxes that we're getting right here from our location data. All right, let's give things a run and see how it looks. Click that play button. Now our main activity just has a button that immediately navigates us to our location activity. And of course our location activity immediately attempts to connect to the service. We can see it's connected to the service because we have that start time got updated. But we don't yet have any location information. Why is that? Well, that's just because our emulator doesn't provide us any by default. We have to come in here and do that ourselves. So my emulator has the ability to enter it right here and just hit send. So we'll go with that. I hit send and ta-da! There it is. Now on a real device, your GPS is constantly sending this data, but on our emulator, we have to manually do it. So we can see that that is successfully updating anytime I change these values. So everything is working correctly. So the two types of services we've looked at so far, started services and bound services, each have some very specific limitations. A started service will run when we call start, and it will just keep running no matter who's connected, no matter what's going on, until we call stop. In fact, it will often even be restarted by the operating system, even if it has to be stopped for memory pressure reasons. Our bound service will not keep running. It will only run when it actually has a client connected. But, of course, with a client connected, we have a lot of interactivity and control. The started service has the limitation that we don't have any interactivity. When we start, it's kind of fire and forget. So this is where a hybrid service comes in. A hybrid service isn't any official naming from Android. It basically just means we're going to use the started service technique to start it, and then we're going to bind to it. So in other words, we're going to be responding to both the onStart command and the onBind APIs. When we do things this way, it will start when we call start, and then it will just keep running until we call stop self or stop service. But in the interim, it allows us to bind. The key point here is that when I've started it through start service, it will not end when my binders unbind. It will just keep going. If it was started through start, then it will not automatically stop just because we unbind. So we kind of end up with the best of both worlds. Let's take a quick look at a demo of using a hybrid service. In your Part 4 resources, there's a demo folder, and this solution, this demo solution, is for a hybrid service. It's actually the exact same location service. However, we've added a class here, so our application class now, an Android application class, will start when the application starts and load even before any activities do. And you can see that in this modified version of our app, we have an application class, and when our application gets created, again, before any activities, even the main activity, our start service is called. So because we're starting our service, that same location service, we start it before any clients bind to it. What that means is that the service will not end when the clients unbind from it. They'll just keep running. And they'll run until we call stop service, which of course we don't actually do until the entire application terminates. Now we can actually see this behavior by using that start time text box that we have, because that start time is showing the location service start time, right? Not the time when it's bound, but when the actual service itself started. I'll show you what I mean. Let's go ahead and run the app. Now, just like before, when I click show location, we're going to create a location activity and we're going to bind to the location service. Okay, so we have 52822. Now, before, our binding would have also been what created the service. And then when we left, our service would have its only bound client disconnected, and therefore the service would be destroyed. However, in this new version, we've actually started our service through start service. That means our service is going to keep running regardless of whether there's a client connected, which there currently is not. Meaning, when I navigate back to my activity again, my location activity again, I'll end up binding to the same service instance. And that service instance will stay around until stop service gets called. So notice clicking this again, same time, same exact service instance is running. And that'll remain true no matter how many times I do this. And so that is what a hybrid service gets us, is the fact that we can have a service continually running. This is obviously extremely useful for a lot of scenarios. Think just about your music app. Your music app, you want to keep playing music when it's not got a client connected. It should still keep playing music. We don't want the music to stop just because our client's disconnected. However, when we have a client app open, we want that client app to be able to interact with the service. And so this is where obviously these hybrid services come in handy. They're actually very, very common because of their power. All right, let's get back to that slide deck. So in this section, we looked at how to create bound services, creating our service binder, our service connection, how to actually bind to the services using those, looking at binding notifications, and then dealing with hybrid services. Guys, that's it for our AND210 lecture. Thank you very much for joining me. Don't forget to check out the exercises if you didn't do those along with me. Bye for now.